Okay, good afternoon, everybody. Thank you for joining our virtual lunch and learn. Sorry about the couple of technical difficulties there, but Jeff's on now and I think we're ready to go. I'm Richard Restuccia. I'm Vice President of Water Management Solutions at Jane Irrigation. And again, wanted to thank you for joining us in this very unusual time right now that we're all experiencing. But as I've said before, we're all in this together. We wanted to figure out how we could best keep the training and momentum for water conservation and sustainability moving forward. And these virtual lunch and learns have been very popular and very good. So thank you. Our speaker today is Jeff Tuel. Jeff is the Executive Vice President of Jane Holdings. And Jeff's somebody I've worked with for several years now. A while back, we both served on the Irrigation Association board together. We work at Jane together, of course, and Jeff's got experience working at Agro Valley Irrigation prior to joining Jane. And Jeff has a lot of extra and other experience in irrigation that's very pertinent to our conversation today. I was very interested to see how much Jeff has been interested and how much work he's done in satellite imaging, as well as soil moisture monitoring, and I've really learned a lot from him over the past few years on both these subjects. I saw him do this presentation at World Ag earlier this year and thought it was just a great presentation. I wanted to give everybody an opportunity to see it themselves. So with that, I'm going to turn it over to Jeff, and Jeff, welcome. Thanks for joining.
Reality here, doing things like webinars and what have you. I'm excited to be here. So if you want, I'll just get started. I think we still have some people joining. At least I'm getting some texts and some emails on my side. And I think, again, it's just kind of the sign of the time. So I'll go ahead and get going, and hopefully people can get in and join us as we go. I'd like to welcome everyone to Jane's webinar on irrigation optimization using remotely sensed EPC and soil moisture monitoring. I hope everyone is safely sheltering in place and doing what it takes to stay healthy. It's important these days. These are certainly kind of unprecedented times. I'm definitely not the professional blogger or webinar guy. Richard is much more adept at that. But what I am is passionate about what Jane is doing to help growers through really an effective deployment of ag technology. And I'm really excited to talk with everyone today. Heck, I'm excited at this point just to do something different that's connected to people, and hopefully everyone can benefit from this. It's really, these seminars or these webinars are Jane's way of staying in touch with the ag irrigation community. And I really appreciate everyone joining us today. And I hope the webinar is informative. We'll have some time at the end to take some questions and what have you. But I'll keep moving forward here. All right, here's our topics. It's a short webinar. We'll cover a number of related subjects, starting with a simple definition of irrigation optimization. Then we'll cover a little about what remotely sensed evapotranspiration is, or ETC. So you're going to hear a lot about that. And don't worry, I'll probably cover it in such a way that some people might get a little tired of that. We'll go over some soil moisture monitoring basics and a few grower examples of applying these technologies and draw some conclusions. And then at the end, I'll leave time for questions and answers. So with that, let's get started.
And Jeff, if I could just interrupt, for those of you who have questions during his presentation,
first,
you can type them into the chat box, and I'll make sure he sees those.
Okay. And Richard, since I have mine on full screen, I don't know if it'll pop up or exactly how I'll see it, but just interrupt me if you need to. All right, first slide here. What is irrigation optimization anyway? The answer is pretty complex, and it's been often debated by industry experts. Some of you probably have been involved in some of those debates. For me, I want to keep it simple and practical. So let's define irrigation optimization as efficiently applying water in frequency, or how often, and duration, which is how long, to precisely match soil properties. Mainly soil properties we're talking about here are infiltration and holding capacity. So we want to precisely match soil properties with plant water consumption to ensure optimal crop yield. That was about as simple as I could put it. In other words, it's about knowing how much water your crop consumed and how much evaporated from the field, also known as evapotranspiration, crop evapotranspiration, or ETC, along with how much moisture is in the soil. Once a grower knows these parameters, he or she can irrigate just enough to replenish the water consumed and the lost ET at a frequency and rate that the soil can hold. And we'll talk, more about these principles as we go. Some of the key factors on this slide that we want to take into consideration are things such as plant growth cycle, soil water storage, weather, energy costs, time of use. When is it most cost effective for me to run my pumps? Cultural practices as far as tilling, low till, no till, et cetera. When do I need to get into the field? Obviously, you can't get in the field if the field's too wet from irrigation. So those all factor in to considerations when you're looking at irrigation optimization. I've had some people, since I gave this presentation at the World Ag Expo, ask, why is irrigation optimization important? The answer is it's really simple, and it should be pretty obvious to everyone. Water scarcity, and we really want to enhance sustainability. I think today there are very few geographical locations on the planet that are not under some kind of pressure, and in many cases regulations to reduce groundwater use for irrigation. A lot of growers, we all feel that pressure. California Sustainable Groundwater Management Act, SGMA, is a good example where critically overdrafted water basin users are now required to formulate and implement plans to become groundwater neutral, which is where outflows equal inflows. Now, to everyone's credit, all the growers' credit, the industry, it's absolutely true that a lot of growers have improved the irrigation system efficiency over the years by using drip, microsprays, jets, etc. So we've gotten more efficient on the irrigation system side. But it's also true that very few have adopted technology that would allow them to run their irrigation systems in a more optimal way. And that's some of what we're going to talk about today. It's definitely no secret to pretty much, I would think, anyone on the webinar today that most growers over-irrigate by using traditional time-based schedules instead of a demand or replenishment approach. So let's keep moving. All right, a lot going on here. Let's talk about measuring a plant's water use using remotely sensed ETC. This technology has been around for decades and is now to a point to where it's refined and readily available to growers. You have state-of-the-art satellites such as Sentinel-2 and Landsat that observe the unique spectral signatures of plant material versus non-plant materials. The models using energy balance models such as metric and Siebel, along with weather station inputs. As you can see, if everybody can see, can't really get my pointer on my other screen. My laptop and my screen have split, so I apologize for that. I won't be able to point on the actual presentation screen. The satellites that are out today are capable of globe scale coverage, and they're getting 10-meter resolution, which equates to about 40 data points per acre. And now they have revisit rates, which means how often they fly over the field to take the images and take readings of 2 to 5 days. All of this raw data is available to the public, but in its raw form is not very usable. I can tell you, after a very rigorous vetting process, Jane decided to partner with a company called Irri Logics, which you can see kind of on the top right there. I could easily spend the rest of our time talking about how we poured through thousands of field data sets from our 12+ years of PureSense data and statistically compared them to Irri Logics EPC. But I'm afraid most of the audience today would probably drop out of this webinar. So it's interesting, and it's interesting to me, but it's not that interesting. I will tell you that Irri Logics is a Bay Area tech company with some really bright people. They're leaders in the field of remote data analytics, imagery, and the use of artificial intelligence to develop their own proprietary models that stitch mosaics of these data sets into user-friendly decision tools. We'll talk about briefly about a couple of these tools now. Okay, so what we have here is HyperView. This slide it's not specifically related to irrigation optimization, but it's important for non-human field monitoring and flagging of possible issues such as pest pressure, nutrient deficiency, soil issues, and of course, irrigation system issues. So I want to talk a little bit about that. HyperView is one of Jane's satellite-based products from Irri Logics, and it's based on NDVI, or crop vigor, NDVI being normalized difference vegetation index, fairly common these days. What you see in this slide is an NDVI image report from HyperView. You know, unlike others in the industry, I'll say, this is much more than just an image. It's really an analytical tool that gives you the actual NDVI vigor, which you can see, you know, called out here. It's 0.48. To the top right, you can see a zoomed in view based around the average NDVI, and that shows also the uniformity of the vigor on the field. The bottom left image only shows pixels where the vigor has changed negatively 10% or more from the last week, and then the bottom right image shows that same analysis as compared to 4 weeks ago. In this case, you can see that the vigor has dropped 10.61% from 4 weeks ago. So in this case, the alert is true. So there's a lot going on here. The difference images that we're showing there, the positive and negative changes in terms of the number of acreages and percentages, and then the alert condition is something very unique to what Jane is offering with HyperView. Let's take a look very quickly at the next. This is the actual part of the email that you get. It's one of the unique things about HyperView. It is an email. So there's no site or software to log on to. It comes right to your inbox. You can have it sent to as many people as you want. And really the most important takeaway on this slide is the alert columns for the 1 week and 4 week comparison periods. We've talked to a lot of growers, and one of the main feedbacks we got was if you have 5, 10, 20, I don't know, maybe 100 or more fields, no one wants to have to pour through image after image trying to spot vigor changes. I've talked to growers that literally set the images out. They pull the last, you know, set of images that they got. Maybe it's a month ago, maybe it's 2 or 3 months ago, depending on what their cycle is. And then they sit and they go side by side trying to visualize, if you will, or analyze with their eyes the change in vigor on a field by field basis. So with HyperView, we analyze that change in vigor for the grower, and he or she only has to look on the email for the alerts. If you see a field with an alert, in these cases, you see a few of the red alerts there in both the 1 week and the 4 week. You simply click on the hyperlink embedded in the email table, and the image report that we just looked at will come up. So you actually get the image of the field itself. It's super quick, and it's really easy. It's a simple way of getting peace of mind that HyperView is watching over the field, seeing changes that the human eye cannot often see. Okay, let's get back to some irrigation optimization. This is we'll take a quick look at the HyperGrow report. So HyperView, NDVI Vigor, HyperGrow. This is where we get our ETC data. This example report is from Shane Burkhardt. He's one of our local Central Valley almond growers that uses these reports, the ETC, and soil moisture probe data to optimize his irrigation. In this case, you can also see that HyperGrow is an email-based product as well. And you have a hyperlink to the ETC uniformity images, which is what's shown at the bottom in this example. You can also see the report shows ETC in inches up in the table and any precipitation reported in the area, along with the uniformity of the field and a comparison of the year-to-date ETC with the year-to-date ETC from the prior year. And you'll also notice out, we also give the percent change. This was really to give growers a feel for where ETC at, water consumption on a particular field is compared to prior years. It's a good metric. It does vary year to year significantly, so we don't expect it to be the same, but it gives you some idea as to where you're at versus last year. The weekly email also provides, which I don't show here, an Excel spreadsheet, and that spreadsheet is full of historical data. It has year-to-date figures. It gives averages, precipitation. There's a tab with a 2-year average ETC water budget and more. We just don't have time in this particular webinar to go through all of that. So if you want to learn more about HyperGrow or HyperView, you can go on the monitoring control section of Jane's website, and we've got quite a bit of information there. Okay, let's move on. This is an important one. This graph is for an alfalfa field showing ETC calculated using the traditional method of multiplying reference ET or ETO by the crop coefficient KC. So you can see the formula up in the top right. This is a pretty common method of getting the calculated ETC, and you'll hear me reference calculated ETC versus, say, remotely sensed ETC from the satellite data. The ETO typically comes from a local weather station, and the KC values are published for all crops pretty much throughout the world, and that curve is shown in red on this particular graph. The green curve is ETC for the same field from Agrologics. And here you'll notice on the green curve the up and down cycles, and most have probably figured it out by now. The grower harvested the alfalfa and then its growth back. So you can see the actual cuttings and the regrowth of the alfalfa with the satellite-based data. The traditionally calculated ETC curve misses these changes in the plant pretty much altogether. It doesn't know when the field is being harvested. It's a mathematical calculation, and it's it's really because it's kind of quote unquote not looking at the field like the satellite is and seeing those changes. The reason satellite-based ETC is so important is that it is specific to the field and crop. Unlike methods using calculated ETC from remote weather stations that can be miles, literally miles away from the field, and crop coefficients that were developed, decades ago. So it's newer technology. We feel it's definitely more accurate. I'm not saying that these traditional methods are bad or unacceptable. What I am saying is they're simply not nearly as accurate or field specific. And in the case of cyclically harvested crops, like in this example, the calculated ET would significantly underestimate the plant water consumption. Now, on the contrary, as you'll see in the coming examples, calculated ETC more often overestimates plant water consumption, causing growers to over-irrigate. In this case, you can see, where you've got a cyclically harvested crop, it's missing those regrowth periods. But before we get to the examples, let's talk a little bit about soil moisture monitoring. We'll do a really quick review of basic soil moisture characteristics. It's not necessarily what the webinar is about, but I want to make sure we're kind of on a level playing field. We all know there are various types of soil: sandy, sandy loam, sandy clay, silt, etc. We won't go into soil types here, but what's most important is the ability of soil to hold water long enough for the plant to take it up. In very simple terms, when the soil is saturated, it starts losing water as it either percolates down past the root zone or puddles and runs off. And it could puddle and evaporate as well if you're not getting the penetration. Field capacity is the upper limit of the soil's water holding capacity when excess water has drained off and downward movement has slowed. So it's a really important, field capacity is one of the most important factors. The wilting point is the lower limit of the soil's water holding capacity, at which point the plant will start to wilt. For irrigation optimization, we definitely do not want to get to saturation. And to ensure an optimum yield, we can't let it go to the wilting point. So really, our target is to keep the soil moisture around the available water holding capacity where the water is available to the plant. All right, that's really the extent of my soil knowledge. So Richard, please no questions on this part. Now, in terms of soil moisture probes, you kind of have a dual purpose slide here. They've really been around and used by growers for many years. It's nothing really new to people. I wish they were more widely used. The idea with a soil moisture probe is to find a location in the field that is considered marginal soil. You don't want to put it on your best soil, and you don't want to put it on your worst soil. So we see the best practice in this case is putting soil moisture probes in what's considered marginal soil, something in the middle. You want to choose a probe length that will cover the target moisture zone for the rooting depth of the crop that's being monitored. This will really give the best representation of the moisture in your soil profile that is available to the plant. This illustration on the slide shows a common soil moisture probe image with multiple sensors in a sealed tube spaced 12 inches apart in this example. For orchards, we see most commonly 48 or 60 inch probes with 12-inch spacing. And then for a variety of row crops, we see mostly 24-inch with some 12-inch and 36-inch probes mixed in. And that sensor spacing can be anywhere from as close as 4 inches to maybe 6 inches in order to, to get a view of the soil profile that you really want to look at. Okay, moving on. Soil moisture monitoring basics here. So We've already discussed most of the elements on this slide. It's a great image to show the various elements we've talked about in a traditional soil moisture chart. Helps kind of pull things together. The left or y-axis depicts the percent volumetric soil moisture, and the bottom x-axis represents time. Sorry, I flipped those around. It should be left is y and x is the bottom. So volumetric soil moisture left, time along the bottom. The plotted curved line that you see there in the darker color represents the volumetric soil moisture over time. So hopefully everybody's kind of oriented to this graph. For me, there's one key element here, and that's the target moisture zone. You can see that in the middle, the clear space in the middle. As you can see, it's well below the saturation point, and it's well above the permanent wilting point. You can see the upper fill point boundary. Everybody can pick that out just above the field capacity, and then there's a lower boundary at the allowable depletion level, and that's there, you know, to give a safety factor prior to the onset of stress. I'm sure our university colleagues attending today can attest to the fact that you could do a PhD thesis on all the factors involved here. There's a lot of study, a lot of research that goes into, you know, the things that the dynamics that are going on this particular slide. However, practically speaking, the takeaway is to determine your target moisture zone and to manage the irrigation to keep water available in this zone. Make sense to everybody? Sound pretty easy? Let's see what's next. So this is kind of pulling that together. You know, how do we know what our irrigation or precipitation water is doing in the soil? Well, pretty simple. We chart it. We chart the sensor data from each one of those levels from the soil moisture probe. Excuse me. I have two charts on this slide, and both are from our Irrigation Logics software. The one on the left is the traditional soil moisture chart with individual graphs for each of the sensors at their various depths. I'm sure everyone that has looked at any soil moisture probe charting has seen this type of graph. It's the most commonly used. You can see at the bottom of that chart, there is a pressure, which gives the pressure in the irrigation system. And that's really there to tell us when and how long the irrigation events are. So each one of those upticks on the bottom of that graph on the left is indicating an irrigation event. So let's look at the third irrigation event from the bottom, and you can see by the increases in soil moisture at each of the depths that this third event pushed water all the way down to the last sensor at 56 inches. So you can see if you just you know, with your eyes kind of make your way down from 8 inches to the 56 inch, you'll see an uptick in the soil moisture. So you can tell that made it down to 56 inches. And you had two other irrigation events prior to that, so you had some moisture in the soil, and you can look backwards and see that as well. If you jump over after kind of an extended period of no irrigation, you look at the fourth irrigation event, that only registered at the 8 inch depth. And then if we jump all the way to the fifth event, that one reached down to 48 inches. So you can see the blue line at 48 inches where it turned on. And then later you can see a slight increase at the 56 inch level. So this is kind of just orienting everybody to reading these charts. You know, the bottom line is there's a lot going on here, and this traditional chart can be a bit difficult to interpret at times. So Gene developed an approved wetting front chart that you see on the right. In this chart, we made it easier to visualize the desired moisture zone. And there you can see it's shown in green. over the entire range of the soil moisture probe. And in this case, you can see on the left, the axis is 60 inches. The irrigation events in this slide, in that chart, are shown by the blue vertical bands that extend from the top to the bottom of the chart. And rain events are similar, but a gold color. You can see those, off to the right. It's clearly labeled. The darker blue shapes coming down into the chart are showing the actual depth that the water is reaching. So at a quick glance, the user can see exactly how far they are pushing water down into the soil, allowing them to more precisely manage both the frequency and duration of the irrigation events to get water into the desired moisture zone. I mean, obviously, being above that is not helping as it should. So you want to push water down into that desired irrigation zone, and going past that is really wasted water. Let's see. So really, by looking at that, you can eliminate under and over irrigating. This new tool, I can say, has been very well received by our users, and it is leading us to more automated irrigation, where we'll be able to, we can tell growers exactly how long and often they need to irrigate based on ETC, coupled with machine learning on the infiltration rate to push the water just where the plant needs it, when it needs it. And we're there. We're working on this as we speak, and that's definitely the next step in ag tech. All right. So let's jump into some of the examples. We have a pretty solid foundation on ETC and where we're getting that. Soil moisture monitoring, the basics on the soil moisture monitoring side of things. So let's look at a few examples of growers applying technologies towards irrigation optimization. Here we have two growers that use Irri Logics along with ETC and soil moisture monitoring. These examples show the cumulative application of irrigation water in orange, so the orange line's there, and the lighter blue bar at the end shows the precipitation stacked, which shows the total amount of the water received. So on both of those images, you can see the stacked bar at the end is really the total water applied. The blue lines show the ETC as calculated by their water district. And in both of these cases, the grower was able to save a significant amount of irrigation water by using technology to more precisely irrigate. Grower 1, you can see, did not take advantage of the precipitation, whereas grower 2 took advantage of the precipitation and really maximized the irrigation water savings. In both these cases, the crops were almonds, and the fields were relatively close to one another. I'm not sure of the age of the trees, but it is clear that ETC varies from field to field, even on the same crop. And in these examples, we're seeing more than 21% water savings. And I would say, we see in other instances the same, anywhere from, I've seen as low as 15% and seen as high as 38% water savings. Let's keep moving. All right. So here, this slide shows the results from 4 fields over 2 years in a before and after scenario. In this example, the blue lines represent the irrigation water applied. The pink lines represent weather station-based calculated ETC. In this case, the ETC was from the California CMS data. And then the green line represents remotely sensed ETC from Irri Logics. Now, obviously, just by seeing the data from 2016, the grower realized they had significant variation in the amount of water they were applying from field to field. And this is not uncommon. I mean, large growing operations, they have many different ranch managers. Ranch managers are given a fair amount of autonomy. You have different guys that might have different practices. And so it's not uncommon to see a fairly wide variation in the irrigation amounts. I don't know the exact number as far as savings in this instance, because growers are a bit shy about sharing numbers. No big surprise there. But I was told the water savings with the deployment of technology and the use of following the ETC from Irri Logics had water savings north of $1 million on the whole operations. In this case, with no effect on yield, as far as there was no loss on yield. Okay, let's take a look at our last example here. This is not really an example of the deployment of technology. This is a retrospective example that I wanted to show. And this is for tomatoes. And this is, like I said, an after the fact analysis. So in this case, we're trying to show the grower what they could have achieved. And so in this case, we took the applied water that's shown by the blue line, and we plotted the Irri Logics ETC as the red line. And in this case, I'm showing the weekly results as well as the cumulative results at the bottom, on the bottom graph. And the tomato transplant took place in mid-April, and you can see where the grower, pretty much poured the water on for the first 3 weeks. If you look at the weekly graph, there's a small, what I think is a weather-caused dip in late May that year, and then the plants really started taking off. You can see the ETC start increasing significantly. The grower, in this case, was probably using calculated ETC as the irrigation events seem to track fairly consistently above the satellite-based ETC. As they got closer to harvest, if you look out to the right, you can see a reduction in irrigation getting ready for harvest. And you can also see the plant's ET respond to less water. And the plants are typically pretty stressed by the time they are harvested. I probably should have run one of the NDVI or vigor images at the kind of in the middle of the season, end of the season, so you could actually see that stress coming on. But looking at the cumulative graph down below, the difference between the applied water and ETC is about 6 inches or 16%. So, we're asserting that they could have saved 16% by irrigating more closely to the actual crop's consumption of water. Now, the principle, we've covered are the same for row crops with a shorter growing season. We're working on the other row crop results and are seeing as much as 38% overwatering to 7% underwatering. So there's a mix, and I think we expect that. Again, it's different practices, and different growers, frankly, schedule water in different ways. So I think we've got a lot more to learn there. I think we need to try to convince more row crop growers to invest in technology and to dig more deeply into irrigation optimization opportunities for these important crops, because we do see fairly significant opportunities to save on the water side. And when you save on water, you save on pumping cost, and water is not getting cheaper, it's getting more expensive. So the return on investment is definitely there. All right, let's draw some conclusions. So we've talked about a lot of different things here. Hopefully this was pretty clear. Try to keep it fairly basic, but in summary, remotely sensed ETC is more accurate and reliable. It is field specific, and we see water savings possibilities of 15 to 20% or more as compared to the traditional ETO times KC curve calculations, or using no ETC, just using, say, time-based or some other method. It also provides plant stress indicators in actionable areas within the field. So you are getting images associated with that. ETC uniformity, according to the research, is directly correlated to yield uniformity. So you can think of that as, if I have poor ETC uniformity, I am going to have less yield than I could have. So it's a good indicator on how your crop is doing. Soil moisture monitoring provides critical information about the water available to the plant in the soil. It also tells us how often and how long to irrigate in order to keep the water in the target root zone. And this helps prevent over and under watering. I did forget to mention this before, but by keeping the moisture in the root zone, you're also keeping costly nutrients in the root zone for plant uptake. We see graphs quite often, and grower puts out a bunch of water and they fertilize the week before or some days before, and there goes the nutrients blowing right past the root zone. So it's just another key application of using this technology to not only get better yields, but more cost effectively use the inputs that you're putting out on the crops. So by combining field specific soil moisture information with the satellite ETC, the grower can very precisely irrigate to replenish the water consumed in amounts and application rates to ensure the water is in the target moisture zone. Putting too much water on the field means it will run off or drop below the root zone where it's not available to the crop. Not to mention, it would be in excess of the plant's consumption. That's one of the things we see quite often is when you put more water than what the plant is consuming, or I'll just say more than ETC, the soil can only bank so much. And we talked a little bit about saturation, points, etc. So this is really why balancing the amount of water that we're putting out and replenishing what was consumed using the soil moisture probe like a fuel gauge, if you will, to determine how much you need to put back in. So water savings are achievable, we think, year round, but the greatest savings come in the shoulder months of the spring and fall when ETC is lower. Obviously, summer is the peak ETC time. So during these times, it's also possible to take advantage of rain events. It's something, I think some growers do a better job than others with soil moisture monitoring and ETC data. You can definitely take advantage of it. Those are some of the biggest gains we've seen. And you can see the soil water holding capacity, and you can see that you do not need to irrigate. So in some instances, we've had growers skip irrigation altogether for a few weeks where they've had enough moisture banked in the soil from rain events. So, and those are significant cost savings. I guess the last thing I want to say, it's really important to understand that these results are not from under irrigating the crop. We're not suggesting that, but the results are from reducing over irrigation by more precisely irrigating to the plant's needs and managing the soil moisture in the target zone. That's all I had today, and I would be happy, Richard, if we have time to take some questions.
Yeah, thanks, Jeff. Great job. Very interesting. I really appreciate that last point too, that we're not deficit irrigating, we're just irrigating to where we should be. A couple questions were text to me earlier. The first question I had has to do with the messaging from the AgriLogics report. Is that a weekly? Is it a monthly? How often do we see that, Jeff?
That's a really good question. It's a weekly report for both the Vigor, the HyperView, and the ETC. So we've changed the schedule around a little bit. So now it comes out on Saturdays, and we try to get it out on the weekend because we got a lot of feedback from growers saying that's when they plan or schedule their irrigation for the coming week. And it seems to be, good timing. So it's weekly on both of those reports.
Okay, that's great. And then I can also get an annual email too. Is that right? Well, not an email, but not a report, but just something I can use for scheduling my irrigation for on an annual basis. Is that right?
Yeah, we've modified that a little bit. So what you get now, instead of just the one, I'll call it the annual budget, water budget, that's in the HyperGrow report, which is the EPC report. That now is being included with each week report, and it gets continuously updated. So you get the cumulative data as you go through the year. So there's a running year-to-date total for the water, but there's a tab within the spreadsheet that comes with each report weekly. And that particular tab doesn't change. It is the annual budget that you're talking about. So it gives you the average ETC for the field by month for the prior 2 years. And then at the end of the year, obviously, when we start into, say, January, that gets updated to the most recent 2 years. So each year you would get an update on that.
Yeah, that's great. So really, I can really track year over year off this report, right?
Absolutely. And what's been interesting for me, and I was certainly no expert on this, and after just looking at hundreds of fields and looking at the data, it honestly has been pretty amazing to me, the variations in ETC from year to year. We just went through a little bit of a cooler spell here. We just had some rain. If you compared that to last year, the year before, we had some record rains. We had a hot spell that came early in the year, and then that got followed by a bunch of rain for a couple weeks, and you can literally see the ETC change, year by year. The 1 year when we had, I think, the record 100 days, consecutive days of 100-degree weather, ETC was kind of going through the roof. So that's why it's important to be field specific with this data and to look at it every year. And I think the weekly rate works really well from the irrigation scheduling side.
Yeah, that's great. So I've got another question here, and it's from somebody who does irrigation planning on tomatoes. And they want to know if there's a way to get predicted ETC for a week out so I can irrigate more accurately in my irrigation.
It's a great question. I've had the conversation with Sumer, the founder of AgriLogics, and mathematically they can do prediction. They tried it in the beginning, and these guys are super smart, MIT masters, mathematics, computer science, et cetera. So they really understand numbers and modeling. And after they tried it, they said it will work, but they just didn't feel like it was as good as putting back the water that was taken out in the prior week. You know, ET doesn't vary that dramatically from week to week in most instances, unless something really crazy happens from a weather standpoint. So we really felt like the more, I'll say, accurate approach was to look at actual ET from the prior week, look at what moisture is in your soil, and then top off the soil by putting back in the water that was consumed from the week prior. I mean, there's nothing that's going to happen that week coming if you keep your soil moist and you've got the water that's needed banked in the soil. You're going to be fine in that coming week as long as you keep up with it. Now, we have had, so sorry for this little bit longer answer, but we have had instances where you get into the hottest part of the summer and maybe the irrigation system was designed just to meet peak ET, maybe a little bit of a buffer there. So growers can get in situations where they're barely keeping up. And if they miss an irrigation, they get behind. And I can't tell you how many growers I've had say, you know, if I miss an irrigation or if I, God forbid, I miss 2 irrigations in the summertime, I can't catch up. I can't put enough, you know, water back out there. So it's a long answer to say, yes, we can do a look ahead. It's just that we hadn't found it to be as practical or as efficient as the replenishment method.
Great, thank you. So I've got another question, and that is, have you correlated yield with water savings on fields yet?
You know, I would love to do that. And if there's any growers on the webinar that want to volunteer for that, I would be all in. You know, most of the time growers don't want to share actual yield data, but what they do tell us, I'll say anecdotally, is in all of these cases yields were as good or better than any other year, whether they, you know, after the water reduction and following ETC more closely and managing the soil moisture, yields were not affected adversely. But I would love to do some of that correlation.
Yeah, that'd be really interesting, wouldn't it? So, and then I think we have just one last question here. Yeah, and the question is, does AgriLogic work on drip irrigation as well as sprinklers?
Yes. So AgriLogics, by the very nature of the satellite, it's really interesting in that when Gene was vetting AgriLogics, we sent them, a few hundred random fields. We didn't even tell them. All we sent was a polygon. We didn't even tell them what the irrigation was or even what the crop was. And that's how we tested them to see how accurate they could be in the dark. So really, the satellite is looking at the stomata, if you will, in the plants and how the plant is responding. So it makes no difference whatsoever what type of irrigation. We are running those reports on drip, jets, flood. Flood can be kind of interesting. You can definitely see vigor patterns in flood fields. And you can also see instances where irrigation, say the ends of the lines are plugged or getting plugged because the grower has not done proper maintenance and has not flushed those lines. And you can literally see the vigor start dropping at the ends of the fields. And then they go out and flush and things come back. So again, kind of a long answer, but I think it was a really good question.
Yeah. So we have a quick follow-up too. How big does the crop have to be before the satellite picks it up, right? If you're just doing little transplants of small plants, does the satellite pick that up?
It does. So when on the tomato graph, I can back up you know, in this case, those were planted on April 13th, and you can see within a week there's a small, you know, uptick. If I were to zoom in on that, you would see that if there's something green on the field, if there's a plant on the field, it will see it. So when you say size, the resolution is 10 meters by 10 meters. So it's about 40 points, data points per acre. So yeah, it's what we see is very accurate reporting. But I will say, the greater the vegetation level, the more bright you'll see the vigor. I mean, it very clearly comes through. And but resolution's 10 meter by 10 meter. That's the size of the pixels that the satellite is looking at.
Well, Jeff, thanks so much for taking us through this today, as always. And it's very interesting, and I certainly learned a lot. I know the viewers did as well today. So I want to thank everybody for joining us. Appreciate you working through the technical difficulties at the beginning. I want to let you know that we'll be doing this again this Friday, and we will be talking about drip irrigation for hemp. And Michael Derwenko and Kevin Stewart will be making that presentation. We'll also get a thank you out with Jeff's contact information if you have follow-up questions to make to Jeff. And we'll also send a link for Friday's training as well. Again, thanks very much, everybody, for joining us. And we'll see you at our next virtual Lunch and Learn. Thank you.
Thanks, Richard. Thanks, everyone.